Free fall. So we're going to do free fall problems here. So how do you identify something as being a free fall problem? If only gravity is acting on it. So if the only thing acting on it is gravity, you have yourself a free fall problem. And what that means for you is that the acceleration in the y direction is going to be negative g. Now g here on Earth is 9.8, so we're going to get an acceleration of negative 9.8 meters per second squared. So let's see how this plays out in a problem. So here I have a ball being dropped from a height of 1.5 meters, and I want to know how long does it take to hit the ground, and what's the velocity just before it hits the ground, because as soon as it hits the ground, there's something else acting on it other than gravity, the ground, and it no longer is a free fall problem. So we can only do from the instant it's dropped to the instant before it hits the ground. All right, now it is moving in one dimension here, so I can set up my one-dimensional motion problem in order to solve for time. Now, because I can also identify it as a free fall problem, I get to put in the acceleration as negative 9.8 meters per second squared. It also uses the word dropped for me here. So drop tells me the initial velocity is 0 meters per second. Some more information I can pull out of here. So I'm going to choose this as a height of 0 down here at the ground. And so it ends at the ground, or very near the ground for our purposes. And it starts at a height of 1.5 meters. Okay. Now I need to find time, and I need to find final velocity. So in order to find time, I'm going to need to pick an equation that doesn't have final velocity. So that's our equation number 2. It looks like this. So I have y equals y naught plus v naught t plus 1/2 at squared. So let's cross out some stuff. So it ends on the ground. Its initial velocity is 0 because it's dropped. And now I just need to go ahead and solve for time. So I'm going to subtract that y naught over, equal to 1/2 at squared. Multiply both sides by 2. Now I'm going to divide the a as well, gives me t squared, and now I got to take the square root. Now don't worry, you see that negative sign in there, that's okay. We have a negative on our a, so those two negatives will cancel out. So I have the square root of negative 2 times 1.5 divided by negative 9.8. And so you get a time of 0.55 seconds, so 0.55 seconds. Now, one thing to remember is be careful of when you're writing out that S for seconds, or you maybe write it out at SEC, that S doesn't turn into another 5, okay? All right, the next thing I want to do is find the final velocity. All right, so let's go ahead and find that final velocity. So let's assume that I didn't find time. I just wanted to find V final right away. So I'm going to pick an equation without t. An equation without t is equation number 3 for us that says v squared equals v naught squared plus 2ay minus y naught. Okay. Going ahead and canceling stuff out here. So it initially is dropped and it lands on the ground. Okay. And I'm left with v is equal to the square root of 2a times negative y naught. Now those sharp math students out there are seeing something. They're saying, hey, will you take the square root? I noticed it with time last time, but I understand, time has to be a positive value. But what about the plus or minus here? Well, what does a plus or minus tell us for velocity? It tells us the direction, so we do need to include it. Good thinking there. So now, which one is it going to be? Well, the direction of the velocity right before it strikes the ground is negative, so I'm going to want the negative here. So v is equal to the negative square root of 2 times negative 9.8 times negative 1.5. And so I find that the velocity when it reaches the ground is going to be negative 5.4 meters per second. Okay. So there's that negative, and that's where it comes from. It comes from that plus or minus on that square root sign. And so this is how you do those free fall problems.